Hello. Today we are going over transformation of parabolas. So what we kind of went over in 7.3 and 7.4, but now we're going to start translating them. We're going to move them around, left, right, up, and down. So we have what we call a vertex form or descriptive form, which we've all seen before. So this is the form we're used to seeing, right? H and K is the center, A value, all of that. Now for sideways parabola, we have same idea, vertex or descriptive form, but now y is being squared. So it's y minus k squared plus h. Okay, so that's for sideways. So this is our traditional up and down parabola. This is now left and right. So that one's kind of new. Now we also have what we call focal width form. So this is helpful because remember 4c is what is called our focal width. So that's the distance between those 2 points on the parabola, the focal chord endpoints. So this is, again, right, y is being squared, so this is, again, a sideways parabola, left or right. And here, x is being squared, so this is a vertical parabola, up and down. But again, the 4c is the focal width. So focal width form is nice because it allows you to find 4c and you can work backwards. You don't have to do all that 1 over 4a stuff. You don't have to work with all the fractions. So if you're comfortable with focal width form, it is actually algebraically a little easier to work with. So remember, we use the a value to find 1 over 4a, which is called our focal length. Okay, so again, what's nice is you can, if you have focal width form, you can forego the 1 over 4a and use the 4c and kind of work backwards to find c. So as I'm looking at example 1 here, this is in what we call focal width form. So what I'm saying is if you recognize that this is in focal width, it's easier to find 4c. But before I move on, I forgot a part. The vertex for all 4 equations is hk. So think about that, right? Look at the signs. Minus h plus k. So opposite the same. That's what it's always been for parabola. This is where it gets tricky. Now it's opposite for k, same for h. Okay, that's a little bit different. So when you're working with the sideways parabolas, again, it's a little bit different. It's h and k. So look for focal width form. It's opposite of k and opposite of h. Opposite of h and opposite of k. So you really have to pay attention what form you're in. Now, one way to get around this is to always put it in vertex form. So then you can eliminate focal width form and just focus on these 2. That makes it a little easier because it's always opposite of what's in the parentheses and the same as what's outside. That makes it a little bit easier if you want to always put it in vertex form. And that's what you're actually used to the most. That's what you saw a lot of in Math 2 and we saw a lot of earlier in this class. So a lot of students like to just keep it in vertex form. But again, focal width form has its advantages. So back to what I was saying. This is what we call focal width form. That's helpful because 8 is 4c. So 2c would be half of that, and c would be half of that. So look how easy that was to find c. So focal width has a big advantage when it comes to finding c because it's real simple, right? It's just, you could divide 4c by 4 to get c, or 2c is half of that, and c is half of 2c. So it makes it real easy if you recognize that to find c. But let's say you didn't see that. We're going to put it in vertex form because it asks us to. So divide by 8. So x plus 1 over 2 divided by 8 equals y minus 2. Add 2. So we can write this as 1/8 x plus 1 squared plus 2. So there we go. That's vertex form. That's what you're used to seeing. And notice it's x squared, and it's positive a, so this is going to open up. So to find the vertex, it's opposite. Again, when you're in vertex form, it's opposite of whatever's in the grouping symbol and same as what's outside. So now if we didn't recognize that 4c was 8, we have to use c equals 1 over 4a. So in our case, a is 1/8. So this is why focal width is nice, because I don't have to do all this algebra. So 4 over 8, which is 1 over 1/2, which is, oh, look at that, same answer. So again, focal width is nice because it gives you the focal width. It gives you 4c without having to do any math. You just have to look at it. So it's easier to find c in the focal width form. But that's new to you. You literally just heard about that 10 minutes ago. So since it's been shifted left 1 up 2, I'm going to go left 1 up 2. There's my vertex. My focus is going to be 2 units away from that. How do I know which way? Since it opens up, I'm going to go up 2. So my focus would be at -1, 4. The directrix is opposite of what I do for the focus. So I'm going to go down 2. So that means there's a horizontal line that goes through that point. So that would be y equals 0. The focal chord endpoints, it's still the same as it was the last 2 lessons. It's just now been, the graph's been shifted. So it's still going to be twice the length of C, so 4. Which, guess what? If you would have done focal width form, we already knew that. So I'm going to go right 1, 2, 3, 4, and left 1, 2, 3, 4. How do I know I'm going left and right? Because it opens up. So I always go to the focus, and I'm going 4 units from that point, and it opens up, so I'm going to go sideways. So this would be at 3, 4, and this would be at -5, 4. And again, the order which you write these does not matter. You could write -5, 4, and then 3, 4 if you want. And that's to make sure we did our math right, because 4c, which is 4 times c, should be 8. So this distance here is 4. This distance here is 4. 4 plus 4 is 8. So there we go. So sketch my parabola. There we go. And again, the whole idea is to be able to sketch the parabola, and you need 3 points. We find the vertex pretty easily, but then we have to do a little bit of work to get the other 2 points. Okay, so now if I look at example 2, okay, this looks different than 1. So here, y is being squared, and it's a +1/2, so this is going to open to the right. And this is what we call vertex form. So we don't have to convert it to vertex form. So to find the vertex, again, in vertex form, descriptive form, it's opposite of what's in the grouping symbol. So that's a +3, but look it says y. So the y coordinate is 3, and that gets students all the time. It's y. So opposite of -3 is +3, but that's the y coordinate, and it's same as what's outside. So in this case, it's the x coordinate. So you got to be careful with that. So -2, 3. And again, it's a sideways parabola. So when we find C, right, we're going to go to the right because it opens to the right. So you go right for the focus. So 1 over 4 times 1/2, which equals 1 over 4 over 2, which is 1/2. So I'm going to go right 1/2. So this would be at -1 1/2, 3. Or -3/2 if you want to write it like that, or -1.5. And the directrix, I would go left 1/2, and there's my vertical line. So x equals -2.5, or -5/2, or -2.5. Your endpoints is still going to be 2c. So if c is 1/2, twice would be as big, would be 1. So up 1, down 1. So there's my sketch. So the endpoint would be at negative 1.5, comma 2 and negative 1.5, comma 4. Again, how do I know I'm going up and down? I go to the focus, and I'm going up and down because it's opening to the right. So I go up 1, down 1. You always go to the focus to find the endpoints. So that's why it's helpful to draw this little sketch here in red so you know what your graph should look like. Because that's another mistake that's often made, is students go the wrong direction. So you need to know first what form you're in, because a lot of you are going to probably want to put it in descriptive or vertex form. So it needs to be either x equals or y equals. Second, what does the graph look like? Does it open left, right, up, down? Because that's going to help you when you start to sketch it. Because again, you guys are so used to doing a parabola that goes up or down. In the last couple days is the first you've ever actually seen parabolas and graphed them going left and right. So it's new to you. So it's just not ingrained in you to be able to go left and right yet. It just takes practice. So that sketch that I circled in green will help you remember, oh, God, I'm not supposed to go up. I'm supposed to go to the right. Oh, wait, I'm not supposed to go down. I'm supposed to go left. It's kind of like a check to make sure you're doing the right thing. Okay, let's look at example 3. So let's put this in vertex form. So I'm going to divide by negative 4. So negative 1/4 x minus 2 squared equals y. Remember, vertex form, descriptive form, is going to be x equals something or y equals. Since it's x squared and it's negative, I know the graph's going to open down. And it's x squared. That's why I know it goes down or up. It's negative 1/4, so it's down. So C would be 1/4a. Right? To find the vertex, we go opposite of what's in the grouping symbols. So positive 2. And there's nothing outside. It hasn't been added or subtracted, so it hasn't moved up. It's just moved right 2. So 2, 0. So to find the focus, we need C. To find the endpoints, we're going to need 2C. So 1/4 times 1/4. 1/4/4. So 1. Technically, it's a negative. But all that means is you're going down 1. So down 1. So this would be 2, comma, negative 1. And if I went down for the focus, I go up 1 for the directrix. And you could do a solid line or dash, does not matter. So y equals 1. Remember, focus is a point. The directrix is a line. So if C is 1, 2C, which is twice as big, would be 2. So to find the endpoints, I go to the focus. I know the graph's going to go down, so I'm going to go right 2. And I'm going to go left 2 from the focus. So 4, comma, negative 1, and 0, comma, negative 1. And there are my endpoints. And if I did this right, 4C, which is 4 times C, would be 4. So this distance from the orange dot to the orange dot better be 4. And it is. It's 2 and 2, which is 4, which is what it's supposed to be. Excuse me. Again, how do I know it opens down? Well, first off, it's negative. So it's either left or down. And since it's x squared, it's down. If it would have been negative y squared, it would have opened to the left. To find C, I use my 1/4a. Right? Find the vertex like we always have. Right? In this case, it's been shifted right 2. And that's it. Found the focus, and then the directrix, you go opposite of whatever you do for the focus. So if I went down, I go up to get the directrix. And the endpoints are twice the length of C, so 2C would be 2, so I went left and right 2 to get those orange points. Wait, 4. Graph the parabola with the focus negative 3, 2, and the directrix of 1, and then write the equation of the parabola in descriptive form. That's the same thing as vertex form. So the focus is negative 3, 2. The directrix is x equals 1. So what would be the vertex? Well, the vertex is in the middle between the two. So it would be right in the middle. So -1, 2. How do I know that? Because the distance from the orange dot to the blue dot is 2, which should be the same distance from the blue dot to the orange line, which is 2. Right? That's C. So 2C would be 4. 4C would be 8. So if you were to make this sketch, right, 2C is 4, up 4, down 4. So this is the parabola that we're trying to find the equation for. So I'm going to use the formal definition, which we did earlier in 7.3. Now there's other ways to do this, but just because I want to make sure we practice this. So remember, the formal definition is that you pick some random point. I don't know, let's say it's that red dot. The distance from that red dot to the orange dot is the same distance from that red dot to a point on the orange line. So we're going to show that those distances are the same. What is that red point? I don't know. I'm just going to call it xy. So I'm going to show the distance from xy to -3, 2 is the same distance from xy to the point on the directrix, which is 1, comma, y. Because it says x equals 1, so I put 1. I don't know the y coordinate, so I'm going to call it y. So I'm going to show the distance between these 2 points is equal to these two. And by doing that, I'm going to create and derive the equation of that parabola. So remember, the distance formula is x minus x1. So x minus -3 is +3. You square it. And then it's y minus 2 squared. And then you take the square root. And then you do the same thing for the other side. So x minus 1 squared plus y minus y squared. And you square root. Okay, so let's get rid of the square roots, right? That's not that bad. We just square both sides. So this becomes x plus 3 squared plus y minus 2 squared equals, well, y minus y is 0. So this is just x minus 1 squared. Okay, so it's a sideways parabola. It opens to the right. So descriptive form is going to be y equals, sorry, not y equals, it opens sideways, so it's going to be x equals a times y minus k squared plus h. So we want it to look like that. So if we want it to have y squared, right, we already have that right there. So we're not going to do anything with that. We already got part of the equation. I have to have only one x. So I got to get rid of some of these x's. So I'm going to have to FOIL that out, so then hopefully something reduces. So x plus 3 squared, right, is x plus 3, x plus 3. So if you FOIL that, right, x plus 3, x plus 3, x squared, 3x, 3x, 9. So this would be x squared plus 6x plus 9 plus y minus 2 squared. Again, FOIL, x times x is x squared, 3x, 3x, and then 9. Again, I know I'm doing that kind of quickly, but I expect you guys, you can pause it and FOIL it out. I expect you guys to be able to do that. And then x minus 1 times x minus 1. X times x is x squared, minus 1x, minus 1x, and then plus 1. So x squared minus 2x plus 1. Okay, so looking kind of good, right? The x squares are going to reduce. Whatever we can... I don't know. Let's see. Subtract 1, and then, well, let's subtract 9, and let's subtract 6. So we have y minus 2 squared equals minus 8x minus 8. Okay. So it's starting to kind of look like what we want, right? We're kind of getting this form. Okay, so what we could do is notice there is a negative here, negative 8 we can factor out. So negative 8 would give us x right, plus 1. And, okay, so, well, that's nice. What we just ended up doing was now this is in focal width form. It does say descriptive form, so we got a little bit further, but we just got it into focal width form. Right, here's your 4C. Right, that's 8 units. Oh, look at that, our 4C. Oh, look at that, 8. So we're good there. So we would divide by negative 8. So negative 1/8 times y minus 2 squared equals x plus 1. Subtract the x, the minus 1. Whoops. And then there we go. There's our equation. So let's check. Our vertex is opposite of what's the y. So 2, perfect. And same as the outside, minus 1, perfect. 1/8 is what my a value is. If we plug that in, we'll get c is 2. So there we go. So there's my equation. So again, I use the distance formula to show the distance between, again, I just picked some random point. I don't know, I just picked a random point, called it xy. And I'm showing that distance between that point and the focus. So that's here on the left side of the equal sign. And the distance from that same random point to a point on the directrix, which is the right side of the equal sign, I showed that those distances were equal. By doing that, I derived the equation of my parabola. Again, a lot of algebra. We'll continue to do this to get better at it because it is definitely a very challenging algebraic problem. So make sure you answer your essential question with a 3 to 5 sentence summary. You'll be done with your notes then. Have a wonderful day.